Hi, my name is Chuck Ladwig, and I'm going to be presenting my LabVIEW project for Engineering 267 OIT Spring 2019. So I have my signal generator and oscilloscope in the same VI. Starting with the signal generator, I have controls for amplitude and frequency and a multiplier of that frequency, so that gives you a fine and coarse control. Offset voltage for the output of the signal generator, and a readout for the amplitude and frequency, waveform select, and the ability to add white noise. If I turn this on, start a waveform going here. So I can control my amplitude, as you can see, finer frequency control and the coarser frequency control. I can change the voltage offset here, and it's reading out the amplitude and frequency. I can choose between the sine wave, a square wave, triangle wave, and a sawtooth wave. I can add white noise here, uniform white noise, and I can change the amplitude by adjusting the slider. And for Gaussian white noise, I can adjust the standard deviation here. And for the oscilloscope, I have a trigger to trigger on the leading edge of the waveform, and I can control my volts per division here and my time scale here. I'll crank this up to 20 kilohertz, and you can see it just barely picks that up. I'll slow this down a little. Alright, so I also have controls for the cursor here. We can make them both visible, and I can move those wherever on my graph. Grab the other one, and I can see the position here on this cursor legend. I can also move the cursors in small adjustments here. I also have some basic arithmetic to do the difference between the two cursors, so I can get my delta in milliseconds along the x-axis and delta in voltage along the y-axis. I have some control over the plot line width, and then I have readouts for the RMS value, max voltage, min voltage, mean voltage, and peak-to-peak voltage. And I can control my offset here, and it has a reset function to go back to its original position. Then I have the ability to save data by clicking this button, and it'll save for a period of time into a Word file, which we can see right here. And I can also do a screenshot right here. That'll save a JPEG file in this default directory. I'll call it test1. And if we look in that folder, we can see my file right here that I just created. And I also have control or the ability to see the full Fourier transform spectrum here, and I can adjust that along the frequency spectrum here. And this is the file that it created, the Word file. It has listed data points over a given period of time. And this is the image that we saved right here. And I believe that's everything. Turn that off, and thank you very much.